Let's begin our final presentation. This will give us a chance to actually do a demand-side application, and we are going to focus on looking at the updated data and some tools for setting up a simulation rather than focus on analysis through the demand system. We'll wait for that until we get to the welfare. So we've got a simulation to do for this module. What we're going to do is implement an income tax shock on labor in sub-Saharan Africa. That variable would be TINC. It's an income tax. It's not a particularly interesting experiment, and we'll see why. But we do have some things that we need to keep demonstrating in these simulations, really about learning to set up, run, and to find results. And so because the demand system, it's more interesting from an equilibrium context to start tracking backwards through the P-priv and thinking about the price indexes. Until we know a few more things, we're going to hold off on doing analysis there. And instead we're going to focus on a couple of tools. One is called the CMF start file. It's actually a command file that gives you some flexibility to create sets that help set up policy experiments. So it's very important, an important thing to remember, an important thing to have an example of. And so we introduce that now. And then the other thing, we'll talk about tax rates. So next module, module 4, in addition to the price system, we'll get the policy variables under our belt. And so it'll be important for us now to go ahead and look and see where the taxes live. So several times I've mentioned that the difference between evaluation at basic price and producer price, well, those two differences give you the tax, the actual levy amount, the value flow. And so it must be related to the tax rate. And so we want to know how to check on those tax rates, since most of our simulations will be talking about adjustments to the rate or the power of the tax. Okay, we're going to go ahead and we're going to load version NCORS 3x3, our normal version. If you still have it open from the last presentation, that's fine. We're going to go to the shocks page and clear the shocks list. And then we want to shock some income taxes on labor in SSA, and we're going to hit them to a target rate of 2%. So I'm giving you the final rate of income tax on this labor. And we would have to ask, is this an increase or decrease in taxes? We don't know what the initial tax rates are. And we of course need to know, how do we accomplish finding out whether it's an increase or decrease, and then of course setting up a simulation to run this. And so our simulation tools are going to be the tax rates file and the CMF start file. Remember, the tax rates in this model, or the taxes themselves, are the ratio of two value flows. So if the model has a measure of a value flow at one price and then the same value flow at the other, then the quantities in the transaction are the same. So the only thing is different is the pricing. And so one of the prices must have a wedge or a top-up or a levy added. So there's a taxation that happens. And so it is the case then that instead of just thinking about these in terms of prices, we could just, since the quantities are the same, they would cancel out in a ratio. We can always find taxes in the model by taking the ratio of two value flows. We want to know the tax rates in the initial equilibrium. And we can certainly calculate those. We could go in and find, we've already looked at these in the previous presentation, where we had one value flow measured at basic and one measured at producer pricing. And so we could take those ratios and work our way to the taxes. But as you might expect, with RunGTAP, a framework built for solving the model and for helping new and experienced users set up simulations, run them, and do analysis, that tax rate information is already available, and we can see it if we go to View, Base Data, and Tax Rates, and that's what we'll do now. Okay, I now have my RunGTAP open to NCORS 3x3. I mentioned I was going to clear the shocks list, so I will go ahead and do that before I come back. So view base data, and you probably already noticed this is here, but it's the tax rates. And so when it opens up, go ahead and make it large. You'll see, just like any other data file in GTAP or in GTAP, RunGTAP, all these headers here, and they all start RT, basically letting you know that it's a rate of taxation. Now, if we move all the way to the right, you'll see that the different tax rates are being listed. So these are the long names of the labels that go with these headers. And so here's the tax rate on commodity C supplied by activity A in region R. So it's an output tax. Here's the income tax, RTIN, income tax rate on endowment E supplied to activity A in region R. And if we open that up, and we can narrow down to sub-Saharan Africa, and we could even narrow it further to one of the two versions of labor. So this model for the fixed factors, or the primary factors, has unskilled labor and skilled labor. And you can see we're already out to 4 decimal places here, but they're just zeros, right? These are not taxes. These are rounding errors. But we can just take it down to the unskilled labor, and you just see basically a bunch of zeros. There are no taxes. This is in the initial equilibrium. So when we institute a 2% tax, we are raising taxes in this model. We're not lowering them. So those are the values we found. The coefficient is RTINC. You can read it right there. So that is the coefficient this data conforms to. The selectors I have were unskilled labor, all activities, and SSA. And so we really have the question, why are these zero? How do we investigate those? Well, we might need to think more about GTAP database construction. Hate to keep saying it, but it's an advanced topic. Sort of what are the decisions made in setting up an IO table and the sort of social accounting matrix for a single region, from all the different data that we have. But for now, in a sort of functional sense, how did these come to be calculated to be zero? We can find that out through looking at another tab file, another text file of code, Tableau file, looking at view, tab files, and shocks. That shocks file is going to be where all these tax rates are calculated. So I'm going to go to view, tab files, and then here we're going to select shocks. That will open up for me a file called shocksv7.tab, and this goes with version 7 of GTAP. So remember, our code version is GTAP v7, so it has the shocks v7. This will look pretty normal to you as you move down through here. You'll see some declarations of sets, declaration for a data file, and then we have a section here that's called base revenues and expenditures at producer prices. So shocks v7.tab is actually going to go read the core data file, pull in those coefficients that are relevant for calculating taxes, and go through and calculate them all. It actually does a little bit more than that, but we'll take it step by step. Under these base revenues at producer prices, you'll see something that looks familiar, VDPP, domestic purchases by households at producer prices. If we kept scrolling, we see another section, base revenues and expenditures at basic prices. That's the comparison we need, right? Basic versus producer pricing. And so if you scroll just a bit more, we'll find the partner to VDPP as VDPB. So private household expenditure on domestic C in our basic priced. So we have the two things that we've already said need to be taken in ratio form to give us the tax rate. And so we can move on down through this and find out how exactly that income tax is being calculated. Okay, if you move a little further down here, you'll see all the reads. So it is coming from the file GTAP data at the headers we might expect. Now, unfortunately, those coefficients like R, T, I, and C are not going to show up in here. You have to drop the R off of those if you want to search for a specific tax rate. But it's also a short file, so it's easy to scroll around and find your way. It is literally just reading in data, calculating some ratios and another measure, and then reporting them back out so that they can be displayed. But I'm going to go with search find TINC, search forward from the top, and you'll see that I get to a set of information here. So a coefficient, and I knew what I was doing, but two, it took me right to where I wanted to be with something that's actually called TINC_L. And in fact, every tax rate in this code is written just like this, TINC_L. And in fact, we're not calculating rates here, we're calculating the power of the tax. When we do those ratios, a value of 1 or larger implies a tax, less than 1 implies a subsidy. You'd have to remove the 1 to get, subtract 1 from it, multiply by 100% to get the tax rate in percentage terms. And so we're working exclusive with the power of the tax. The tax rates file of data that we were reading goes ahead and does that extra step. This file is actually only calculating the initial level in power terms of the tax, and then everything else can be derived from that ratio. So we've got the base power of the income tax on endowment E supplied to A&R. That looks like what we're after. And so you see it being declared there, and then a second measure is being declared right after it, TINC_hat. And again, if you look around, you'll see everywhere else that when you calculate 1_L, right after it you get something called _HAT or hat. And that is what we're doing there, is calculating the shock that would remove all of the income tax. So the hat is implying like a little hat over a variable or a change that you would need to implement. And so here we have it, the two relevant data flows for the income tax, TINC_L, EVFB divided by EVOS. So measuring at basic prices and then producer prices. So in this case, that's the supplier price, EVOS. So when we're talking about the income tax, the supplier, the producer, is the endowment agent, and then EFB is the market clearing price, or the market price being paid by firms hiring from these suppliers. So producer price, basic price. What's this second equation doing? Well, if this is the base rate or the base level of the power of the tax, how would you get rid of it? Well, you calculate a reduction if it's a tax, an increase if it's a subsidy, that would need to be done to bring that power of the tax back to 1. So if the power of the tax here, if these are equal, that means there's no wedge, there's no value gap between the supply side valuation and the purchase side valuation. So a power of a tax equal to 1 means that there's no instrument, or the instrument is set to 0. And so if it's not set to 0, then this becomes, this measure down here, this TINC hat, just says, what would it take to get this back to a value of 1? And so you take 1, subtract off the actual level, divide it by the level, and multiply by 100. That will give you the percentage change to the power of the tax that returns you this target level of 1. In fact, it's an elimination calculation. It's the power of the tax shock that you would need to implement to get rid of the tax. All the simulations, all of the things in RunGTAP that calculate shocks for you work off of this shocks.har information. So it goes through and calculates, one, the initial power of the tax in the base data, two, what level of change or of adjustment would need to be made to eliminate the instrument, to bring it to a tax rate of 0 or a power of tax of 1. And then everything else can be derived from that, because everything else is just some partial version of eliminating the tax. If you want to cut the power of the tax by 100%, that's what this shock is. If you want to cut it by 10%, well, you take 10% of this value.
Okay, here we want to think a little bit more, kind of summarize. This slide is organized for you to have these notes that summarize what's going on in the shocks module of GTAP. So that includes shocks.tab, the code that we just looked at, and then whatever pieces of data it pulls in. And so if we go back down here to the part of code we just looked at, you see a couple of coefficients being designed, the income tax level, the income tax adjustment that would get rid of all income tax. And then we have to come up with a formula for both of those, and the first one is going out to the core data. And so down here I've copied the two core data pieces. So over here it says we could check the core data items EVFB and EVOS to see what's going on. And so EVOS written here, EVFB written here. So this is the order they would show up if you were reading down the core data. They're not side by side. I've pulled them, clipped them out of the core data file, this one being very near the top, this one being down towards the middle of the headers. And you see here that the values are very close. These are aggregates, right? So this is for all the endowments, all the activities, all the regions. What's the total value if you add it up in the EVOS matrix or the EVFB matrix? They're essentially equal. So there are some small sort of smudge factor income taxes living in the database, but none of them are very large, right? And so we get this sort of slight difference, but essentially 0. So they're really when we shock this, it's very likely we're going to be shocking from a 0 value, for that experiment. But this is the way it works for all transactions in the model. Every transaction that has a potential tax wedge is going to appear in the shocks module in the code. That code would tell you or document for you what ratio of values you're looking at. So sure, we're going to have slides, and we'll have another discussion of this in the advanced portion of the course about where the taxes are in the GTAP. We're going to give you slides and tables, and if you look at the JGEA paper that documents version 7 of the model, it'll have a listing of all these. And that's appropriate to have those all documented somewhere else. But the code is also documentation. So don't forget that RunGTAP gives you all of these tab files to look at. You can see how GTAP view output is calculated. You can see how the shocks are calculated. And of course, the main tab file tells you how the model runs. And so all of these things, all of these relationships captured in the code, documented for you.
Okay, so we know a little bit about the tax rates in the model and the initial tax. We know there are no taxes, and that what our simulation we've proposed is going to do is raise taxes on labor supplied to some activities, maybe all activities. And it's going to be, those shocks are going to take the tax from what would be a 0 rate to a 2% rate. We're going to target the rate. So if we looked at the data, we'd see there are 2 types of labor and 3 activities that labor can be supplied to. So let's implement our tax on income from all labor types in non-farm employment. So in our model, food contains the farm sector, and so we could put those sort of non-food sectors aside and say, let's tax not on the farm but in the other sectors. So we have some options for how we might set this up. We could go and pick and choose every time and set up a shock and build the model that way, build the scenario that way. So each one we get for each labor type and each sector we want to shock, We put it in, we say target that to be 2% and set it up and let it run. Or we could do something different and do some kind of a new local set that said, let's treat labor as its own subset of all the primary factors. And since I want to hit them, I want them to both have the same target tax rate of 2%. If I could write that as a single shock and have GTAP or RunGTAP understand it and just go and do that, it would be much easier for me to look at, easier for me to implement, and just more convenient, especially if I have several, a long list of shocks. Begin to think about things like regional free trade agreements, where you are going to zero out a bunch of tariffs from one region to the other. You may want to set an entire category of tariffs, and so if you could build a set over what has been negotiated, and that's what we're going to do here. Okay, so the first example, I said we're going to do it both ways, and so for the first example, I've gone ahead and printed this out on here so we can talk through it, and then we'll go and actually implement it. So example 1, I have written here shock TINC, and then for the second one shock TINC. So the first one says unskilled labor, the second one is skilled labor, so that covers both of the varieties or both the types of labor. At the end we see sub-Saharan Africa, so I'm targeting the region I intended to, and then over here we see target %2. That is the nomenclature for setting the final rate to a target value of 2%. Okay, so you will, through experience, see that when you add different types of shocks, there's different notation written out here. That's why you want to use RunGTAP, because this has to be specific, the spacing has to be correct. But the final thing is, you see it says from file tinc.shk. The shocks file wrote this file. Okay, so when that shocks file ran for us, we didn't run it. It runs automatically in the background for GTAP, through RunGTAP. So tinc.shock gets created, and it creates that tinc_hat, that change variable that will set the income shock, the income tax to 0. And so it's reading from there to find this target of 2% value. But our puzzle for the moment is, what is this? This says in food acts. And so if we look down here, that's the question I'm asking. Well, it's a set that is all the activities. Remember, productive sectors are called activities. It's all the activities except food. It got dropped out. So where would that be defined? It's not in the GTAP v7.tab file. We haven't explored all of it yet, but I can promise you it is not sitting in there somewhere to find. So our task now is to go find that. Okay, join me over in your RunGTAP. Move back to your version. Be sure you're in the correct version if you've been in and out reloading. Ideally, RunGTAP will open to the last version you were using, but always go and check. So we're in the NCORS 3x3. And what we're going to do now is look for this file called CMF start. So if you're looking for something, you don't know where it is, go to view, and it turns out it's right here. So this is the CMF start. It's command file, run at startup, if that helps any. So it's a sort of auxiliary set of commands. So at the start of any GIMPACK simulation, a command file is read. RunGTAP is a lot of things, and one of the things it is a large command file writer for GIMPACK. So all of these tabs we're doing where we select different things, those actually, while they look like we're running, we're doing all these selectors, well, what it's actually doing is sort of setting the structure of the command file, and when we click solve, the first thing that happens is RunGTAP writes the command file. Well, one of the options we have is to augment that using this CMF start. We can write some things at the bottom and get some initial commands code introduced into the model that doesn't have to be in the model proper. And one of the things we can do is build a set. And so if you click on open or view the CMF start file, the first thing it'll tell you is click help to learn about the CMF start file. Help in GTAP and RunGTAP is actually very good. It is the documentation as you need it on demand and quite thorough. Now I know a lot of software does not have good help files, or they're too complicated. These are really written for users. The documentation is sort of elsewhere in terms of PDFs, in terms of deep dive, but if we open that, you would get a quick overview of what the CMF start file is. I'm going to click on OK to open it so that we can look at it. Okay, so you see it opens as a tab file, so it's opened alongside the other tab files we've opened during this module. And if you read down through here, you'll see some commands that are going. CPU, NDS, extrapolation, accuracy file, use 2 processors if possible. So this is just some different information, and where you see a exclamation point, it means that's turned off, or a comment. So that's a comment, that's a comment, that one's turned off. Summary, decomp, GTAP, vol, those are different files that can be produced as part of the simulation run. The summary file, the decomposition of welfare, and the volumes. So you want quantity, volumes, you can get those. But what we're interested in is what comes right after all that. So this is always there in the CMF start. We're interested in these statements that follow, and these statements are really just building up some interesting or useful sets within this dynamic of the auxiliary command file. So you build a model, you build the sets, the code is already compiled. It's compiled to run efficiently, to run as fast as it can. But the sets got loaded in from the data file, right? Remember, we looked at the sets file. They're in a HAR file. And if you wanted to read those in separately or read in a new subset, you'd either have to recompile or change the sort of structure in that HAR file reading in the sets. Neither one, which would be straightforward, and one of them would be quite difficult to reconfigure. So what this is just a recognition that users, that people doing scenarios, are going to need lots of flexibility. And so you can come in to this CMF start file and start creating your own sets. And so the notation is to always use, these are called X sets. They're extra sets that are used on top of what lives in the declarations in the model code. And so someone, it wasn't me, but someone who built this in-course 3x3 said, let's make a food activity set. And so what they did was they said, used a statement called X set food acts, and then this parenthesis just tells which elements belong to this set. And so the food commodity, or the food activity, I guess is probably a better way to say it, belongs in food acts. That's a set, and now we need to declare it as a subset, because it is actually a subset of something else, and that will let us do another piece of information here. So if we follow it up and say X subset, so an extra subset, food acts is subset of ACTS, so it's a subset of the activities. Then if you declare it as a subset, then you can do a set operation on it, so that you move down here and you have X set in food acts equals activities, right, the productive activities minus the food activities. And so that is where that set we saw came from. So it's in food acts. Okay, that's about as simple as it gets. You can see they did a separate one here where they said, well, we have the activity set, but there's also this mirror set that is on the commodities. So there's a productive sector that makes food, and then in the commodity set there's a food as well. And so here's just the mirror. So XSET FoodCom also takes that, and then the subset, or sorry, the set operations to take that away from commodities. Remember, these will only be different, the activities and the food sets, if you have something that isn't a diagonal on that make, that we were talking about, the advanced topics in production. It's possible to have a sector that makes 2 commodities, or and that be the only sector that makes those commodities. So in that case, you'd have more commodities than you do producing sectors, or you'd have more, in set terms, you'd have more COMM than you do ACTS. Okay, so there's some more stuff here that's been done, one of interest to us, but for now let's go back to the simulation and try it out as it was written on that PowerPoint page. Okay, so we're going to use our selectors and set our scenario. So I'll choose here and move down. I know I want TINC, so you can reference the slide we were looking at. And now you see the elements that you can choose from. So under this one, I'm going to select first unskilled labor. It's the first one selected on the slide. Then I'm going to check all in food acts, and that will cover everything that isn't the food sector. Now I'll take only SSA. For the type of shock, I want a target rate, percent target rate, and then for the shock value, I want 2. Click Add to Shock List, and you get something that matches exactly what we have on the slide. What's the second one we want? We want, instead of unskilled labor, we want skilled labor. It is also for the in-food activities, also for Sub-Saharan Africa. The target rate is 2%. So these are correct. So we can just click Add, and you get a preview right here of what it would look like if you clicked Add to the shock list. So you can always check if you have a reference like I do, or like you do now for yours in the slide. You can always read this and make sure it makes sense. Click, and we have our solution, or our simulation set up. Let's go ahead and run it. Go to solve. You can see I've already prepared a name, tax on labor income and SSA. If you would like, click yes, and keeping in tradition of really just typing in about anything, I'll just put test tax 1, click.
So we should be picking up with an accuracy summary here that you can match up to. And so we'll go ahead and click OK. And even though later in this course we're going to spend a lot of time, especially when you get to phase 2, digging through results, we still want to check on results, right? This particular presentation, this particular component is really about learning some technique for setting up experiments. So we set our shocks back here, 2 different components of labor to give us an increase in income taxes on labor. And that's an experiment, but we want to use that experiment where we use 2 shocks and see how we might combine it, and then we'll talk about why that technique may be useful. But for now, let's just open the EV, and we see that there's all 3 countries have a result, right? A change in the equivalent variation from this labor income shock. So Sub-Saharan Africa, of course, being taxed has the negative effect, and then the 2 other places get some ancillary benefit, some responsiveness to these income shocks. So we won't spend any more time on the results, but we want to peg this result because we're going to try to run this simulation a different way, do a little bit of modification to the model, to the command file, the instruction set for the simulation, and we want to be able to check and make sure we get the same result from aligning these shocks one by one. Okay, so what we're after here, we notice the set of non-food activities. Okay, so those are the production sectors, the activity units that use labor, right? That hire labor, but aren't food. Okay, so it's manufacturing and services combined into a subset of all of the activities. Well, that looks useful to us, and if we look here, we see that we have two types of labor, and there could be, especially based on the kind of experiment we've set up, there could be a reason for us to try to put all of the labor types. So in this model, we have two types of labor, unskilled labor and skilled labor. If you continue with GTAP, you'll find some models with 5 types of labor. And if you want to apply something uniformly across those, if you don't want it to be uniform, then you always have the option to go line by line or endowment by endowment. But if we want a uniform activity, then it makes sense for us to have a set that is just the labor endowments. And so that's what we want to do. We want to produce that set. Now, we could go into the code, edit the code, modify the code. You have to recompile the model. It's a fair amount of work, and it's an advanced topic. But the software, as designed, understands that we may want to make some of these modifications, and that we may want them to be specific to the modeling activities that we're doing in our current version archive or in course 3x3. So imagine we're on a research project and we have, the classic cases, we're doing a regional free trade agreement, and we want to have not the full set of regions, but the subset of regions that are in our free trade area, and then the ones that aren't. And we want to be able to apply tariff policies there. And so that's certainly an experience you're going to have later on in this course. But for now, we just want to come up with the same concept, a new set that is just for labor. And so here's how we'll do it. We're going to use something called the CMF start file. We'll go to View. We could go directly to CMF start file, or we could find it in the other text files. But we'll just click on CMF start file. You get this useful reminder to tell you, in general, GenPack and RunGTAP have an excellent help section. If you're about to do something and you think you should learn more about it, lots of times it'll recommend to you to click on help. We know everything we're going to do right now, so let's click OK. And it opens the CMF start file, and you can see where the food activities was defined here, and it said those activities, and in the parentheses it says only the set element food belongs to food activities. Here's the declaration that says that set, where we're only picking the one item, the singleton, is a subset, so it gets to inherit all of the sort of properties of the superset activities with the reduced population, the reduced number of items. Down here it says that food is also a subset of the commodities. Remember, we have this production sector where there's activities and there's commodities, and the model we're running is diagonal, so one commodity per activity. We don't have any multi-product sectors, so we end up with a fair amount of things like this on the commodity or activity side, where we have to come up with a symmetric or treatment to be sure that we're getting everything we want. This final, you can do set operations, These final two lines are where we end up with that actual in-food acts that was set, that was used in the experiment itself. Take all the activities, remove the set or the elements that are part of food activities, and you're left with a new set. And it'll inherit, since we declared this as a subset, it inherits all the properties. It's now connected to a superset activities. So take the superset activities, remove all the things that we declared as part of this subset, you get a new subset. We don't need a separate subset declaration there. Okay, so that's what we want to do, and you can see right here that somebody's already done a subset treatment for land as part of this CMF start file. So land endowments, put land in that set, declare it as a subset, and then make the X set complement, right, everything that isn't land. So that one won't help us because it'll have capital in it as well. We need to declare our own subset, and so we'll do that now. A nice way to do this, if you're like me and you want to be able to look up what you're doing, is if you go all the way to the bottom here, you'll see this to the bottom right where my mouse is. You'll see that you can move the window. You can reassign how much of your screen that TabMate is going to take up. And so I'm going to click this right there. When you do this, it takes up the right half of your window. And you'll get you have a full, this is still the editing, window that we wanted. And now I can see the experiment that I was running, and I can use it as a way to remember what I'm trying to do, right, and to get the exact specification of what these are. So what I'm going to do is use this X set, X subset, X set, this triple of lines as a guide to build a set that, instead of just having land, will have unskilled labor and skilled labor both as components. So I'm going to go ahead and pause the recording, so when this comes back up, you'll see that it's all typed in and you can work from there. Of course, you can pause it to type in your own, but I would suggest first try to use this, the land endow setup, and come up with your own setup, and then check it against what's getting ready to pop on your screen in a couple of seconds. Okay, I've made my edits now. I have taken unskilled labor, UNSKLAB, SKLAB, separated those by parentheses, typed them exactly. So it shouldn't be case sensitive, but always better to make things match in case, but you definitely have to have the set elements written correctly. I believe this will work. I've done LAB endow, and as long as that hasn't been used somewhere else in the model, we're fine. LAB endow is a subset of endow, just like this, and then X set in lab endow. Again, I'm going for the complement just in case I ever want something that, it's just a convention to always make the complement set, it seems to be, in case I ever want to do some kind of separation on what's happening in labor, what's happening in the rest of the endowment set. Okay, so I think the thing to do now is to click Save. You see here it says it's now saved this updated version of CMF Start. Update there is gone, but it told us that it kept a backup, and I think it was called Mate 001. And so you could always roll back to what you had, or we could put in comments so that we know what the extent of what we did. Put a comment. A comment is a line that starts with an exclamation point. We could put a comment above and below to say this is our modifications for whatever day, whatever time, whatever experiment we're doing, so we know how to roll it back ourselves. Okay, so now what we want to do is run this model, and we want to come up with an experiment that I'm going to go ahead and close this. We want to run an experiment that doesn't have 2 lines. If we want the same exact experiment, but instead of having 2 lines, it'll have 1. It'll just say treat everything in labor the same. And the way to do that is to use our new set. So we could clear the shocks list, go to variable to shock, move down to TINC. We've got the variable to shock, the elements to shock. We are now looking for our set. And if you look through here, you won't find our new set. This is at first concerning, but on second thought, should be expected behavior. The only thing we've done is updated a text file. RunGTAP has never experienced that as anything except a text file that now has a later save date. It's never actually, well, you might say, parsed that text file. So what the CMF start file is it's this file that when RunGTAP runs a simulation, it does something called building a command file to hand over to the GEMPACK solver. And so part of that is it goes and reads your closure. It reads everything you've declared in shocks. It looks at what solution method have you chosen, what parameter file have you chosen. It also reads through that CMF start file before it does anything. It runs through that start file and gets its first set of instructions. And so if we look at that, you'll see up here some other instructions that we don't really know much about, right? And we may not to, right? It's telling you here, yes, produce an extrapolation accuracy file. Here is saying that the GTAP summary should be written as summary.har, right? So these instructions we never really pay attention to, but they're part of the instruction set that go with every simulation. And this part down here, these X sets, these are local sets. They're version specific sets. And it basically says that in addition to all the sets that you read in from GTAP v7.tab, tack on all of these sets as well. So if RunGTAP has never read through this CMF start file the way we've updated it, then it doesn't know that this lab endow, this labor endowment category or set that we've made is something it has access to. So what should we do? Let's see if we can force it to read what we have. So I'm going to reload the test tags. I'm going to click on solve, and I have no reason for doing this other than to force RunGTAP to go through and recognize my work on the text file. Okay, so it's just a way of getting RunGTAP to have parsed or incorporated the new sets that have been added to the CMF start file. And if we've done it correctly, then when we now clear our shocks list, pull down and find TINC, and then pull down these, we'll find the lab endow set that we have. All lab endow, all, I believe it was in food acts and SSA. And I believe it was target rate and 2, and add to the shock list. So target %2 from file T shock. And so we're down to 1. One line. It should shock both of those in all the new in food activities. So you can do everything that you know how to solve, you know how to save and solve. Go ahead and do that. Okay, if you've been through, created your shock, solved, you should get the same result for EV to match up. And of course we could look at view updated data, updated tax rates, And this one is the income tax, right? The tax on endowments, the income tax rates. And we could look and see that, let's pull up, remember we're getting sums right here. We're getting sums across regions and we want SSA. So these are the endowments, these are the activities. We're only looking at a matrix for sub-Saharan Africa. We have the twos where we expected them. So if it's labor employed in manufacturing or services, it's getting a 2% tax rate. So, that's all we want to do. And why did we want to go through this? Well, we're still sort of building our skill set, but as I mentioned, the sort of classic use case for these CMF start file modifications and creating your own sets is in the regional aggregates, right? And so, we have a 3-region model right now. And if you wanted to have something that gave preferential treatment to everything but SSA, you would use something like this, right? So this is a region, a set that captures SSA, but let's say that you were saying raise the tax rate not within SSA, or the tariff rate not within SSA, but the rest by a common amount, then that would be the set to use. But you can imagine having a 6 commodity model or a 7 or 8 commodity model with 12 regions and wanting to have bilateral representation of countries, but also being able to treat preferential trade agreements. And if those preferential trade agreements say there's going to be 10% reductions across the board within the preferential trade area, well, this set it's a boon to be able to choose, to be able to declare things like this, rather than going through and listing country by country bilateral pairings. And so it's almost always the case that the CMF start file becomes really part of your model design, especially when you're doing trade models. And so you'll see when we get to the second part of the class, it's one of the things we'll go and check. If you're looking at something like NAFTA trade, and one of the extensions that we look at, is sort of focused on NAFTA and food and agriculture, and you'll go in there and you'll see that we have declared the NAFTA regions themselves, and then the rest of the world treated separately. So just briefly, let's return to the slides. So this is what we did. We created this set and we ran our experiment, and then we went and looked at, in the updated data, the new rates. We viewed that. We could have looked in the updated core data and compared EVOS to EVFP, and we would have seen that where there was no tax before, so that EVOS and EVFP were exactly the same, now we've put a wedge between those. Less elegant, but if you worked your way back from looking at these tax rates, and then you go to the tax rate file, the one that calculates the shocks, and see how the income tax is calculated as a ratio, then you would take you to these two headers, EVOS, EVFP. That ends what has been kind of a long application experience, but again, this is our module on demand. We really have to pick up some more pieces to get into some more advanced GE and simulations. And so what we've done is taken this opportunity to put together a simulation that is sort of linked to the demand or the income, the budget side of the model. But really what we wanted to focus on was how could you set up simulations and do some, run your basic simulation, but then do some post-simulation modifications, look at some updated data to go in and capture what's happened. And as always, you'll have a review quiz for this lecture, and if you have any questions, you should obviously reach out.